All right, everyone, this is the MAT0022 Module 1B notes for the homework. And we're going to work on the highlighted problems starting with number 1. And the question says, which of the following statements is true? Choose the correct answer below. And you see a bunch of options with exponents and the meaning of that exponent. First, I want to review what an exponent looks like. We have two components of an exponent. You have the base and the power. The power tells you how many times to multiply the base by itself. So for example, if you have x to the third power, that means x times x times x. This is our base of x, and we're multiplying it by itself 3 times because our power is 3. Now let's look at our examples. The first one, you have 3 to the 5th power. That would mean 3, that's the base, times itself 5 times. And that's not what we see here. So this one is not correct. Letter B, 3 to the 5th power. Again, we would see 3 times itself. We should be multiplying and not adding. So letter B would not be correct. Although you have 5 3s, you're adding them instead of multiplying them. Letter C, 3 to the 5th power. 3 times 3 times 3 times 3, 5 times. So letter C is correct. Now letter D, we have 3 to the 5th power, just 3 times 5. That's not correct. So our answer would be letter C. Let's move on to number 2. Write using exponential notation. So we want to rewrite our term that's given in standard form. We have a bunch of numbers side by side. We want to put it in exponential notation, meaning we want to add the power. Based on the number of times we multiply that base by itself, I underline the 2 sets of digits that we have in example 2. We have 5 times 5, we underline the 2 5s. We have 4 9s, all right? So to rewrite this term in exponential notation, 5 is the base, and we'll raise that 5 to the 2nd power since there are 2 5s we're multiplying by itself. Times our 9, how many times are we multiplying 9 by itself? That would be 4 times. So 5 to the 2nd power times 9 to the 4th power is the correct answer. All right, let's move on to number 4. You're evaluating this time. So now we know the value that we can learn because we know about exponents. We know that our base tells us that we're going to multiply. The number of times we multiply that base will depend on the power. In this particular problem, we have a power of 3. So 9 times itself 3 times. We should be multiplying 9 times 9 times 9. Now, if we simplify this, we would take these digits as multiplication, 2 numbers at a time. 9 times 9, we probably know offhand, but 9 times 9 gives us 81. Times a third 9, starting with our last column, 9 times 1 gives us 9. 9 times 8 gives us 72. So our answer would be 729. 9 to the 3rd power equals 729. That's a 7. All right, let's look at number 9. Now for number 9 and most of the following problems, you're going to be using what's called the order of operations, and the order of operations tells you how to work out problems when you have more than one operation symbol. Now, when I say operation, I'm talking about addition, subtraction, multiplication, or division. I'm talking about one of these operations. Now, when you have more than one operation, to determine which step to take first, you would follow the order of operations. The order of operations we may remember as please excuse my dear Aunt Sally, or PEMDAS, to P-E-M-D-A and S. P stands for parentheses. E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. S stands for subtraction. Now I put this little arrow here around multiplication and division, but also addition and subtraction, because you perform these operations in the order you see them from left to right. And that's important. Multiplication and division, yes, you would perform one before the other depending on which one comes first as you look at the problem from left to right. And the same thing applies when you have addition and subtraction. You decide which of these to perform first, depending on which one comes first, as you look at the problem from left to right. Now let's look at example 9. We have 36 divided by 9 times, this little dot here means multiplication, times 4 plus 7. Now look at our order of operations. The P stands for parentheses. We don't have any parentheses, so we can move on to the next letter. E stands for exponents. We don't have any exponents, so we're going to move on to multiplication and division. Now we see multiplication and division, but as we read this problem from left to right, which comes first is the division. So we would divide 36 by 9, that gives us 4. And then we'll carry down the rest of the problem. So the multiplication symbol, the 4, and plus 7, we carry those terms down. Next, we have multiplication. 4 times 4 gives us 16. And then we'll carry down our addition symbol and our 7. And then lastly, we want to go ahead and we want to add that 16 plus the 7, so we can go ahead and get our final answer, which will be 23. So for number 9, we get 23. Now let's look at number 10. Again, we have order of operations. Now this little bar here does mean to divide, but we have to figure out what the numerator and denominator are first before we can divide. So we're going to look at each of these terms in the numerator, figure out what the top number is going to be. We're going to simplify in the denominator, figure out what the bottom number is going to be, and then lastly, we would divide to get our final answer. All right, looking at our numerator, we have parentheses. We should perform that operation first. So 6 minus 3 gives us 3. Bring down or bring up, we're going to be working upward this time. The 5 that's in front of the parentheses and the plus 5 behind the parentheses. Now still moving left to right. Whenever you see a number side by side with parentheses, that means multiplication. So this means 5 times 3, which gives us 15, plus the 5, and 15 plus 5 makes our numerator 20. In the denominator, 5 to the second power. Remember that's our base of 5 times itself 2 times. 5 times 5 gives us 25. 25 minus 5 gives us 20. So our denominator is also 20. When we divide 20 by 20, we get our answer, which is 1. All right. Let's look at number 14. Now for number 14, again, you have order of operations. In parentheses, we see 6 times 3 plus brackets 8 divided by, and then in parentheses, 7 divided by 7. All right, now we have different sets of parentheses. So we'll just look at our parentheses from left to right, meaning we'll multiply 6 times 3 first. That gives us 18. Divided by, but we can't divide yet because we don't know what each of these terms are going to be. So let's start with the innermost parentheses. 7 divided by 7. 7 divided by 7 gives us 1. We'll carry down our 1, our division symbol, the 8, and the brackets around those terms. Lastly, 8 divided by 1 is just 8. And keep the brackets there, the division symbol that's in front. And over on our left side, we have 18, right? So 7 divided by 7, we had 1. 8 divided by 1 gave us 8. And in the center, it wasn't a division symbol. That's actually addition. So we should bring it down a plus symbol. All right, we carried down our 18 that was in front. Remember, 6 times 3 gave us 18. And now we're going to add 18 plus that 8 to get our final answer, which will be 26. All right, let's look at number 16. Now for 16, we're going to simplify again. Remember, we got terms in the numerator, terms in the denominator. So I'm going to rewrite the division problem over here to the side so we'll have a little bit more room. That's 7 plus 2 plus 7 to the second power in the numerator. In the denominator, we have 5 in parentheses 18 minus 4 minus 3 to the second power minus 8. Need a little bit more room, huh? So starting in the numerator, 2 plus 7 to the second power. This exponent we need to look at first. 7 times 7, that gives us 49. We'll bring up the addition symbol and the 2 that's in front of the 49. And then we want to add 49 plus 2 in the numerator. That gives us 51. Now in our denominator, we want to start with our parentheses. 18 minus 4 gives us 4 in parentheses. Carry down the 4 and the 5 that's in front of the 4. Behind, we have minus 3 to the second power minus 8. All right. Now our exponent here, 3 to the second power. 3 times 3 is just 9. So minus 9, carry down our minus 8. And 5 times 4. 5 times 4 is 20. Now we see we have subtraction left to right. So 20 minus 9, moving left to right. We want to make sure we subtract first. 20 minus 9 will give us 11 minus 8. And then lastly, we want to subtract 11 minus 8, which will give us 3. So our denominator would be 3. And the last thing we want to do is divide. 51 divided by 3. So over here to the side, we're just going to divide 3 into 51. And 3 can go into 5 one time. 5 minus 3 gives us 2. We'll carry down the 1. 3 can be divided evenly into 21 7 times. Our final answer would be 17. All right. Let's look at number 21. For 21, you're asked to evaluate this expression for the given replacement value. When we say replacement value, we're talking about this x. Given an expression, 9x to the second power plus 2x, but we want to know the value of this expression when x is 4. So I drew arrows here to show you everywhere you see the letter x, you're going to replace it with 4. So let's rewrite that expression, replacing our x terms with 4. So instead of 9x to the second power, we're going to have 9 times 4 to the second power plus 2 times 4. Now using our order of operations, we're going to deal with our exponent first. Although you see parentheses, there's no work to do inside the parentheses. So what's left will be multiplication, multiplying the number that's in front of the parentheses. But we need to work out the exponent first. 4 to the second power, 4 times 4 gives us 16. We'll carry down the 9 in front, plus, and then the 2 and 4 behind the plus sign. Now 9 times 16, over here to the side, you want to just do that multiplication. 9 times 16 will give you 144. Plus 2 times 4, 8. And lastly, we want to add these two terms. 144 plus 8 gives us 152, and this is our answer. All right, let's look at number 24. Now for 24, I want to first start by discussing what each of these groups of numbers represent. First of all, we start with real numbers. All numbers are real. All numbers that can be written on the number line are represented as in numerical form are real numbers. So all numbers are real. We normally start out learning our numbers when we're learning to count. As we're little babies, we learn to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. Those are called natural numbers. So from 1 all the way to infinity, positive numbers beginning with 1 all the way to infinity are called natural numbers. Now, when we take that list of natural numbers, 1, 2, 3, 4, 5, 6, all the way to infinity, and we add a 0 in front, we have 0 plus all those digits, 1, 2, 3, 4, 5, all the way to infinity. This list of natural numbers now become whole numbers. So by adding 0, we make that list from being natural to whole numbers. Now, if we expand this list of whole numbers and we add the negative whole numbers, like -3, -2, -1, still the 0, 1, 2, all the way to positive infinity. So all negative and positive whole numbers, including 0, are the integers. Rational numbers are numbers that can be written as a fraction. So of course, all of these natural, whole, and integers can be written as fractions. We can just simply put ones underneath these whole numbers. So all of these digits would be considered rational. Numbers that can be written as a fraction are rational. And then lastly, all these digits together, if we were to combine every set, they're all considered real. So to answer this question, we're going to fill in the blank. The blank numbers are all numbers that correspond to points on a number line. And the right answer is going to be real. That's the real number, representing all numbers on the number line. And that's the end of the module 1B notes.